Good day, everyone. You are welcome to today's lesson. And in today's lesson, is going to be very brief, very short. Our task here is to look at the solution to the assignment on lesson 8 of what the topic differentiation and calculus differentiation to be specific. Okay, so just as you have on your screen, you can see the solution there with some marks, okay, attached. So indirectly, the solution doubles as what your marking scheme. You is supposed to guide you to do your marking, those who submitted your work, okay, your assignment, and guide you to mark and submit your marked version as well. So without much ado, let's go and look at what the solution. So remember, when you read question, you make it a habit to underline the salient part. So we are asked to differentiate this function with respect to x. So indirectly, once we are differentiating this function with respect to x, it means our differential operator is d dx. We are finding d dx of f of x, which we know will give us f prime of x. That is the actual notation. So after reading and underlining the salient part, if any, there is nothing salient for us to underline. Okay, the first thing that you write is solution. Failure to write solution will be -1. Take note of that. Okay, all right. Then after that, what do? You extract the function that you are asked to differentiate. So that is extracted. If you're able to extract that, okay, that attracts 1 mark for that. Okay, then remember I told you whenever you have this situation where you have products of functions, what do? Expand, okay, before you differentiate. So expand combined like terms before differentiate if possible. So in this case, we can expand. So if you expand, this is what you are supposed to get. You know, you can use the product rule, but by then you've not been taught the product rule. So the only way out will be to expand. Okay, which is what we have expanded here. And as you are expanding, you are not differentiating. So if I see any dy dx or f prime of x anywhere here, it will be m0 a0. Please take note of that. So after your expansion, you know, okay, this is now going to be the refined version of your function that's, okay, for convenience sake, because you want to avoid the product rule and differentiate term by term, okay, you have expanded. So now what do? Okay, you come and differentiate term by term because I'm going to take, so it's now that I'm going to apply my differentiation. So I'm going to find d ds of f of x, which we all know the notation is f prime of x. Okay, so I'll write therefore f prime of x will be equal to, then I come and differentiate. So it will be d ds of this side. Some of you wrote it, that's okay as a guide. Okay, so d ds and you put the whole of this in brackets. If you wrote d ds of this side and you didn't put the whole of this in brackets, take note. And those of you who wrote this, okay, let me quickly see if I can go for those of you who wrote this. You wrote what? F of x, okay, is equal to d dx of this side. Okay, then you put that one will be m0 is a function, okay, will not be equal to, once you applied, okay, dds here, you should also apply dds there. So take note of that. Okay, so that was, okay, just by the way, as a penalty for you to know how to do the writing and okay, so the writing to be done. So now what do? Okay, I'm finding dds of this side, which will give me f prime of x. dds of this side, mentally, I didn't write the dds. I know ddf of this side means I have to differentiate term by term. That was the plan. So if I differentiate this term, I will get this. Differentiate this term, I will get this. Differentiate this term, I will get this. Okay, differentiate this term, it will give me 0. So I don't write it. Okay, so that will equally give you 2 marks. So if you concluded by writing dds of f of x, then it will be -1. Okay, please, dds of f of x, you know is f prime of x. That is the matured notation. Okay, if you concluded by writing dds of f prime of x, that will be a0. dds of f prime of x means that you are differentiating twice. You are rather differentiating f prime of x, not f of x. But the question asks you to differentiate f of x. And those of you also concluded by writing dy ds, that will also be a0. Okay, the function was not y, it was f of x. So you don't conclude in dy ds, which I have, okay, said that on countless occasions. If the function was y, then it means your conclusion will be dy ds. Any other, okay, you will get it what's wrong. So please take note, your total marks will be 5 marks. So you write 5. If you had 5, you write 5/5, okay, on top of your page or below, okay, your final submission that you have there. Then you send it to me. You capture the mark version and send it to me for me to go through and see if you did a good work in terms of the marking. So on this note, I'd want to say thank you very much for your time. If you are yet to subscribe to my YouTube channel, subscribe, like, and share. And if you have any information, anything that you want to bring to bear, okay, don't forget to let me know via the comment section. Thank you very much. God bless us all.